Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topics related to the construction or related to the concrete. That is the formwork. Now, there are different types of formwork is available, but today I'm going to discuss in details about the formwork. Rather, it's about the table formwork, or sometimes it's called the flying formwork. So what is table formwork? What is the component? How to do the formwork? How to removal that one? What is the removal methodology, and where to use and where not to use? In today's video, I will discuss each and everything in details about the table formwork. So stay tuned until then to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject. And the first things what we need to know, that is what is called table formwork. But before that, we need to know what is formwork, what that is very much important. So there are different terminology in the construction, that is shuttering, centering, formwork, staging. So what's that? That we should need to know. So first is short is shuttering. Shuttering is the process of forming the mold or framework into which concrete is poured to give it to the desired shape and structure. So it's forming a mold. And what is the example? Column, wall, etc. So it is for
Formwork.
the,
That
that means if it is a vertical and if it is a forming the mold, it's called the shuttering. And what is centering? Centering refers to the temporary support of framework used to support horizontal member like beam and slab during their construction until they become self-supported. So the centering is the horizontal one, and the shuttering it's the vertical one. And what is the example? Beam, slab, etc. And next is coming, what is the staging? So this is also a part, and it is commonly used in the construction. But what is called staging? Staging in the context of construction typically refers to a temporary scaffold or structure erected to support workers and materials during the construction, repair, or maintenance of a building structure. So this is a temporary support. That's the next part is what is called formwork. So formwork is a broader term that includes both centering and shuttering. It encompasses all the temporary structure used to contain and shape concrete until it reaches sufficient strength. So entire system of false work or the for is called the formwork, including staging, including shuttering, including centering. So these are the things about the four components, that is the centering, shuttering, formwork, and staging. So if you want to know more about this and what is the comparison, I have made a detailed video. You can find out in the description. Please check, you will get the full information about this. Now these four terminology we are using. Now there are different types of formwork. Today we will discuss about the table formwork. So what is called table formwork? Table formwork is a modular reusable formwork system used for slab construction, especially in high rise and repetitive floor structure. It is also called flying formwork because large sections of that is tables can be lifted and reused with the cranes. That means it's forming the table, and after deshuttering, the same table can be lifted and can be placed in the new area. So that is why it's called the flying formwork. Sometime also that is the table formwork. Now, where we can use, there is a high-rise building, commercial building, residential complexes with repeated floor layout, large industrial slabs. And why this table formwork is important? That is the speed of construction, reduces labor requirement, better quality control, reusability, safety, and the also it is giving the good quality or the structure also. The next part is, then we need to know what is the relevant IS code for the formwork. So relevant IS code is first IS 14687 1999, reaffirmed in 2019. That is the false work for concrete structure guideline. This is the guidelines, or this is the mother of all false ceiling of false work. That's a formwork system. It has given the all details about what to do, what not to do, what is the material to be used, what is the load you need to compare, and each and everything in this code. So whenever you are dealing with formwork or the shuttering, you need to follow the IS 14687. Then IS 4990/2024, that is plywood for concrete shuttering works. Because in the table formwork, the main ingredient is the plywood. We are using the plywood for to support the freshly placed concrete. So what is the guideline for the plywood? That is given in the IS 4990/2024. The next is IS 883, design of structural timber in building. Then IS 2062/2011, to reaffirmed in 2021, hot rolled medium and high tensile structural steel, that is used also in the false work. IS 1161, steel tubes for structural purpose. 2750, steel scaffolding. So these are the relevant code you need to follow whenever you are dealing with the any type of concrete, especially in the table formwork. So next is, what is the former component for the plywood shutter or the table shutter? That is the plywood 16 mm we are using, and the beam side we can use the 12 mm, but most of the cases we are using 16 mm for the horizontal one and the 12 mm for the vertical one. Then wooden runner, MS pipe, aluminium beam, HD jack, base jack, swivel clamp, tie rod, cup lock, scaffold, that are all used in the formwork. First component is plywood. In the plywood, what the IS code? That is IS 4990. Now, what is the dimension and tolerance of the plywood is given in the IS 499 in clause 7.1. The any dimension, length, width, and thickness and number of ply as agreed to between the manufacturer and the purchaser may be used and shall also be declared by the manufacturer. Prevailing dimension, that is plywood board, are as given: 2440 into 1220, that is the normal one or the widely used plywood shutter board dimension. But another also you can use: 2135 into 1220, 2135 into 915, 1830 into 1220, 1830 into 915. So these are the given guidelines or given dimension that plywood can be used. But any other shape or any other size that also can be formed in between, agreed between the manufacturer and the purchaser. Now, what is the dimension and tolerance? Because whenever we are getting the plywood, there is always a dimensional tolerance. So what is the dimensional tolerance? In length, it is a +6 and -0. Width is +3 -0. Thickness less than 6 mm, it's ±10%, and 6 mm above ±5%, and squareness maximum 2 mm in 1000 mm or 0.2%, and edge straightness 2 mm or 1000 mm or 0.2 percentage. So whenever you are getting plywood in your projects or in your site, these are the things you need to check. That's the dimensional tolerance, because it is very much important. If the plywood's dimension are not proper or not accurate, the table formwork is become difficult to adjust or difficult to place. So these are the plywood dimension. But what is the plywood strength, or what is the plywood test you need to conduct, or what are the other parameter you need to satisfy in order to accept the plywood for that formwork? So what is that? That is the tensile strength. Now, what is the tensile strength? Here is the, see, one is in the in the grain direction and the perpendicular to the grain direction, because the plywood is coming from the wood and wood has the grain. Now this grain one is along and another is perpendicular. Then what is method described in IS 1734 part 9? The tensile strength shall not be less than 28 Newton per millimeter square in the direction parallel to the grain direction or the phase beneath. So here you can see these are the direction of the parallel grain direction. So these in this direction, the tensile strength should be 28, and tensile strength shall not be less than 26 in the direction at right angles to the grain direction. So this grain direction, this, so directly parallel 90 degree in this direction when you are testing, the tensile strength should not be 26 centimeter, minimum less. But so these are the in the direction of the grain and in the perpendicular direction of the grain. But code has given another parameter to satisfy to accept the plywood, that is sum of the tensile strength in both direction shall not be less than 60 newton per millimeter square. So this direction plus this direction should not be less than 60 newton per millimeter square. So tensile strength is very much important to uh, understand, and you need to send to the laboratory for the tensile strength to find out whatever the in the IS code has given that has satisfied the criteria as per IS 4990. Then other test what you can do or you need to do, that is the moisture content, glue shear strength, resistance to water test, static bending test, and wet bending test. These are also required because you see plywood is pasted in the glue. So these you need to know during the concreting or during the placing or during the placement or handling, this glue should not be removed. So this glue shear strength is important, and the resistance to water test, because whenever you are working in the outside, so there is a water, so this water test also you need to find out what is the resistance. So these are the tests you need to carry out for the plywood. Now as per IS 450, so 14687, what are the load you need to consider whenever you are designing the conformer? Because you need to know the desired load, and accordingly you need to design, and accordingly you need to find out the element like plywood thickness, the HD jack capacity, aluminum beam, secondary beam, base jack. So that has to be find out with the design, and for the design, the IS 14687 has given the clear guidelines. So what are the load consider? The load to be considered as dead load. And what is the dead load? The false work structure, self weight of formwork, and any ancillary temporary work connected or supported by formwork. And weight of another things, and the weight of freshly placed concrete for the permanent structure directly supported to the formwork. So what is the value of that? It shall be taken as 226 kilonewton per meter square. Additional weights fittings shall be included in the self weight of calculation. Actual load of formwork shall be evaluated for use in design. However, in absence of the data, load may be assumed as 500 newton per millimeter square for the purpose of the initial calculation. So these are the dead load is a given the guideline that 500 Newton millimeters for the purpose of initial calculation. Another is imposed load. What is the imposed load? Loads during construction operations shall constitute the imposed load, that is the IS 875 per 2 false work design. Such loads may occur due to construction, personnel, plant and equipment vibration and impact of machines, delivered concrete, lateral pressure of fresh concrete, unsymmetrical placement of concrete. That is very much important. That is why you need to find out or you need to plan the poor sequence to avoid any unsymmetrical placement of concrete, concentrated load and storage of construction material. But what is the value that is in it is saying where allowances only to be made for access and inspection purpose, a loading of 750 Newton millimeters per square should be adequate. So these are the data you need to know about the formwork design, because without the formwork design we should not do any formwork calculation or any formwork erection, because if we are doing that will be a problem for us in typical formwork assembly. Here you can say this is the access path, because it's a very much important whenever you are doing any assembly you need to make a access path to go inside the formwork, if because to check that one or to work or deshuttering purpose. So what is that? This is a laser. This in the it is X direction and this is the Y direction. This is a laser to be installed prior to connect prior to a full, and this is a normal black hook connection, breast and a diagonal bracing, coupler connection, here is a coupler connection, here is also coupler connection, this is a working deck. So these are the standard is a laser. So this is the base jack. So these are the typical formwork assembly, and you need to follow this one whenever you are working on the site. So next I will go for the formwork assembly, how to do the table formwork. You need to know the what is the table formwork methodology, or how you will install the table formwork. Now first what we need to do, first we need to do the aluminum beams. In the aluminum beams they are grouped. Now why this grouped? In this group, in the top flange, you need to fix the wooden batten. Why? In this wooden batten, you need to nail. Otherwise, you cannot fix the plywood. So first, we need to do the aluminum beams are grouped the top flange to fix the batten on it and almost flat at the bottom flange. So first things, we need to take the aluminum beam and we need to fix the wooden batten in the top flange. Then table mold form consists of series of secondary beam which are placed maximum 400 center as you see in the picture. Then the secondary beams are supported by two primary beams placed minimum 2.1 meter apart. Size of trolley is 1.8 meter of width, or depends upon size of the mold. Now this trolley, what is the trolley? Because this is the trolley is the main lifeline of the table formwork, because without this trolley it is not possible to carry the table formwork or deshuttering the table formwork. And the trolley width is 1.8 meter of width, you can see in the picture. This trolley has used is a lifeline. You can carry the formwork in the place, and on the deshuttering you need this trolley. Without this trolley it is not possible to deshuttering work also. Now first you need to find out the secondary beam, fix the secondary beam, then you need to fix the primary beam. Then four prop set. Now it's here is the four prop sets, I think it is generally you are using, but sometimes it is required the six prop head also, depending upon the load and depending upon the structure. You have to design, and according to the design you need to place the either it is 4 or the 6. So fix 400 from the top face of the primary beam, two on each primary beam, in order to fix props. Now this profits, why this profit is in the profits, it will fix in the primary beam, and this prof is this prof profit, the profs will be fixed. Then props are fixed into profits with the help of nut and bolt. After making frame of aluminum beams, we are going to replace densified ply on it, leaving 35 to 50 from all around. Now, this all assembly has done. That means wooden batten is placed on the primary aluminum beam, primary beam placed, secondary beam placed, prof heads placed, and the profs, and then we need to place the plywood on the assembly, and we need to fix it with the wooden batten and leaving it into 35 to 50 from all around. Why? This other area also you need to fix from the other table formwork. After fixing ply with the help of cloth belt, we are going to lift mold and placed on a trolley or hydraulic machine. Then heavy duty jacks are fixed on each corner. Now after making the assembly, we need to place it on the trolley. Without this trolley it is not possible to fix the props or the heavy duty jacks. So that after fixing this, you need to fix this prop Z. And then after framing table hand, mix fixing and ply fixing with the help of tower crane, we're going to leave the table mold and going to place trolley. After placing on trolley, we're going to fix heavy duty jack on the table head. After fixing of the heavy duty jack, molds are again lifted by the tower crane, and we are going to place as required, and we need to fix making the label of the shuttering as required, or you can see in the video itself. So these are about the table formwork methodology, or how we can fix. Now after the concrete, what you need to do? You need to deshuttering. But what is the deshuttering methodology? That also you need to finalize. To deshutter or the remove formwork, you need to remove, because this formwork has to use another place or the for the concreting. But there is a deshuttering checklist. What is the deshuttering checklist? First, we need to verify the concrete strength. So verify that the concrete has reached the required strength for deshuttering. It is very much important to check. Curing period. Ensure that the curing period specified in the project guidelines has been completed. Because without the completion of the curing period, if we are removing the formwork, that is become a problem for the concrete strength and the concrete durability. Then weather condition. Check that the weather conditions are suitable for removing the shuttering, that is no extreme temperatures or rain. Then visual inspection. Conduct a visual inspection of the concrete for any surface defect or sign of incomplete curing. Then substructural stability. Confirm the concrete structure is stable and not prone to shifting or collapse. Then formwork integrity. Ensure that the formwork has not been damaged and is ready to be removed. Then the support system. Verify that any temporary supports or props are correctly positioned and can be safely removed. Then safety measures. Check that all safety protocols are in place, that are the site is secure for deshuttering. Then tools or equipment readiness. Ensure that the necessary tools and equipment for deshuttering are available and in good condition. And then documentation. Review project documentation to confirm that all necessary inspection and approvals have been completed before deshuttering, such as if it is a PT slab, you need to check from the PT vendor or the PT professional who are working in the paper post tensioning work. So they will check and they will inform that the concrete is has gained sufficient strength, and PT tendon is also been stressed. Now it is safe for deshuttering. So you need to check from the PT vendor also. And what is the deshuttering time as per IS 456? That is given in the table 11.3.1 table 1. You here can see here is a for concrete made using OPC, and for concrete made using cement other than OPC, or using mineral admixtures like fly ash and slag. So for the vertical formwork, 16 to 24 hours for the OPC and 16 to 24 hours for the other. Soffit formwork of slab, that props to be refixed immediately, that we called the back propping. I will come later. That is 3 days, and for the OPC other than OPC 7 days. And soffit of formwork of beams, that is 7 days and 10 days for the other than OPC. And props to slab. See, that means you can remove the shuttering, but immediately you have to reprop or the back prop. Now, the prop to slab you can remove from spanning up to 4.5 meter, 7 days and 10 days, and spanning over 4.5 meter, 14 days and the 14 days. And props to beam and arches, that is spanning up to 6 meter, that's a 14 days for the OPC and 14 days for the OPC other than OPC. Spanning over 6 meter, 21 days for OPC and 21 days for other than OPC. Now, another clause also given, the same clause 11.3.1, that in case of use of cement other than OPC, or in case of use of mineral admixture like fly ash and slag. Now, in all concrete we are using, that is all has either fly ash or slag or the both, and the microsilic and everything. So we have to check that what are the type of cement, or what are the fly ash, or the supplementary cementitious material we are using, and accordingly we need to always think about this. But whatever it is saying, this clause can also be for follow if you are using fly ash GGBs, but there is a condition or there is a criteria, that is you need to define that in the 3 days 45 strength of cube strength specified strength that has to be achieved. In 7 days, 60% has to achieve, and 14 days, 85% of the specified strength has to be achieved. And if the criteria is satisfied, we can deshutter the concrete. And so these are about the deshuttering time as per IS 456. Now we need to check the deshuttering process for the table formwork. Shuttering works commence on the slab is hardened and PT tendon stretching is completed, and we are getting the clearance from the PT vendor. Deshuttering will be done progressively and back propped immediately. So this back prop is very much important. Lifeline for the table formwork will be placed below the table mold between heavy duty props, and with the help of racking and bar adjustment, strip ply will be removed. And after removing adjacent strips, ply whole table mold rest on trolley, then manually the trolley will be brought to the range of tower crane and lift the required place from there. So these are the deshuttering removal methods. So I hope you find it useful about the formwork and the table formwork methodology. And if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. And if you want to do anything more about quality control and construction, please let me know. I will come with more content like this, and I'm waiting for your valuable comments. From that, for your comments, everybody will be benefited. And thank you once again for watching me.